So let's take a look at derivatives of trigonometric functions. So in this video, we'll be looking at all 6 trig functions and their derivatives. So the first one we have is the derivative of sine of x. The derivative of sine of x is going to be equal to cosine x. Now the next one is the derivative of cosine x. The derivative of cosine x is going to be equal to negative sine of x. Now the next one is the derivative of tangent x. And the derivative of tangent x is going to be secant squared of x. And then we have the derivative of cosecant x. The derivative is going to be equal to negative cosecant x cotangent x. Then we have the derivative of secant x. The derivative of secant x is going to be secant x times tangent x. And then finally we have the derivative of cotangent x. And the derivative of cotangent x is going to be equal to negative cosecant squared of x. Now it might take a while to memorize all these derivatives, and that's completely fine. Just make sure that you do more practice problems, because the more practice you do, the better you get at memorizing these derivatives. So for this next set of problems, let's go ahead and differentiate. So for number 1, we have f of x equals x minus 3 times sine of x. Now when I go ahead and derive, we get f prime of x equals, now because there is a minus here separating the two terms x and 3 sine of x, I can go ahead and use the difference rule and take the derivative of x minus the derivative of 3 times sine of x. So the derivative of x is just going to be 1, and then we have minus the derivative of 3 times sine of x. 3 is just a constant, so we can go ahead and take that outside of the derivative and rewrite it as 3 times the derivative of sine of x. Remember, the derivative of sine of x is going to be cosine x, so we have 1 minus 3 times cosine x. And that's going to be equal to f prime of x, or the derivative. Now for number 2, we have y equals sine of x plus 10 times tangent x. So the derivative y prime is going to equal to the derivative of sine of x, which is going to be cosine x, plus the derivative of 10 times tangent x. 10 is just a constant, so we can rewrite it as 10 times the derivative of tangent x. Remember, the derivative of tangent x is secant squared of x, so we have plus 10 times secant squared of x. Now for number 3, we have g of t equals t cubed times cosine of t. Now instead of x, we have the t variable, and that's completely fine because we can treat it the exact same way as we did with the x variable. But this time we're going to derive with respect to t. So we do have two functions being separated or multiplied by each other, t cubed and cosine t, so we do have to use the product rule. So if we go ahead and find g prime of t, once again we're going to first take the derivative of the first function. So derivative of t cubed is going to be 3t squared, times the second function unchanged, so just times cosine t, plus the derivative of the second function. Now the derivative of cosine t is negative sine t, times the first function unchanged, so just times t cubed. So then I can go ahead and simplify. So we get g prime of t equals, so I can just go ahead and leave 3t squared cosine t just like that. We do have a negative here, so I'll rewrite it as negative t cubed times sine of t. And that's the final answer. So now for number 4, we have h of theta equals cosecant of theta plus e to the theta times cotangent theta. Once again, we don't have the x variable, we have the theta variable instead, but that doesn't matter, we treat it the exact same way. So h prime of theta, we're going to derive with respect to theta this time, is going to be equal to the derivative of cosecant theta. Now remember, the derivative is going to be negative cosecant theta times cotangent theta. And then we have plus the derivative of e to the theta cotangent theta. Now because we do have e to the theta being multiplied by cotangent theta, we have to use the product rule. So once again, in the product rule, we're going to take the derivative of the first function, derivative of e to the theta, just e to the theta, times the second function unchanged, so just times cotangent theta, plus the derivative of the second function, derivative of cotangent theta is going to be negative cosecant squared of theta, times the first function unchanged, so just times e to the theta. So now I can go ahead and simplify. So h prime of theta is going to equal negative cosecant theta cotangent theta. We have plus e to the theta cotangent theta. And then we do have a negative here, so I'm going to bring that negative out front and say minus e to the theta cosecant squared of theta. That's going to be the final answer. Now for number 5, we have y equals x over cosine x. because we have x, a function divided by another function, cosine x, we have to use the quotient rule. So y prime equals, now once again when we use the quotient rule to derive, we take the bottom function, so cosine x, times the derivative of the top function, derivative of x is just 1, so low times the derivative of high, minus the higher function times the derivative of the lower function, derivative of cosine is negative sine x, all over the lower function squared. So that can be written as cosine squared of x or cosine of x squared. Now when I go ahead and simplify, we get cosine x times 1, which is cosine of x. We do have a negative here. Negative and negative will cancel, so we get positive x times sine of x all over cosine squared of x. Now for number 6, we have f of theta equals secant theta over 1 plus secant theta. Because we do have two functions being divided here, we do need to use the quotient rule. So once again, we're going to find f prime of theta and derive with respect to theta, because that's the variable. So once again, we're going to take the lower function, so low times the derivative of the higher function, derivative of secant theta is secant theta tangent theta, minus the top function, secant theta, times the derivative of the lower function. Now derivative of 1 plus secant theta, the derivative of 1 is 0, and derivative of secant theta is secant theta tangent theta, all over the lower function squared, so 1 plus secant of theta squared. Now to simplify, I'm just going to go ahead and distribute to parentheses, so then we'll get secant theta times tangent theta plus secant theta times secant theta tangent theta, which is secant squared of theta tangent theta. And then we have minus secant theta tangent theta times secant theta, that's going to be secant squared theta tangent theta, all over 1 plus secant of theta squared. Now realize secant squared tangent, and the positive and negative versions will cancel, so then we're left with secant theta tangent theta all over 1 plus secant theta squared. And that's the final answer for f prime of theta. Now for number 7, we have y equals sine of x over x squared. We do have two functions being divided here, so we do have to use the quotient rule. So y prime, once again using the quotient rule, is going to equal low times the derivative of high, so x squared times the derivative of the higher functions, derivative of sine of x is cosine x, minus high, which is sine of x, times the derivative of the lower function. That's going to be derivative of x squared is 2x, all over low squared, so lower function squared. X squared squared is going to be x to the 4th. So when I simplify, we get x squared cosine x. We have minus 2x sine of x all over x to the 4th. I can go ahead and factor out x from the numerator, so we'll get x times x cosine x. We have minus 2 sine x all over x to the 4th. And then one of the x's will cancel on the denominator. So then we'll have x cosine x minus 2 sine x all over x cubed. And that's the final answer for y prime. So now for number 8, we have y equals secant theta times tangent theta. Because we do have secant theta and tangent theta being multiplied, we do have to use the product rule. So y prime is going to equal to the derivative of the first function. So derivative of secant theta is secant theta tangent theta times the second function unchanged, just times tangent theta, plus the derivative of the second function, derivative of tangent theta is secant squared theta, times the first function unchanged, so times just secant theta. Now y prime, we go ahead and multiply, we get secant theta tangent squared of theta, and then plus secant squared times secant is just going to be secant cubed of theta. And that's the final answer. Now, there are two important trigonometric limits that are pretty good to memorize in calculus. The first one is the limit as x approaches 0 of sine of x over x is going to be equal to 1. And the second limit is the limit as x approaches 0 of 1 minus cosine x over x is equal to 0. Now, the good thing for both of these limits is that the limit still works if the coefficient, as long as the coefficients are the same. So in this case, we have sine of 1x over 1x. So let's say we had the limit as x approaches 0 of sine of 3x over 3x. The limit, because the coefficients are the same, it's still going to be equal to 1. So if you have the limit of sine of 5x over 5x, still going to be 1, or any number, as long as the coefficients once again are the same. And the same thing works with cosine x here. So let's say we have the limit as x approaches 0 of 1 minus cosine of 6x over 6x. The limit will still be equal to 0. So let's go ahead and find the limit. So for number 1, we have the limit as x approaches 0 of sine of 3x over x. Now keep in mind the limit that we just talked about, the limit as x approaches 0 of sine of x over x equals 1. However, we don't have sine of x, we have sine of 3x over x. But remember that as long as the coefficients are the same, the limit is going to be the same, it's going to be 1. But in this case, we don't have 3 on the denominator, so we have to find a way to get a 3 on the denominator. So what I'm going to do here is we have to multiply by what's known as a clever form of 1. So I need to multiply by 3 over 3, because it's the same thing as multiplying by 1. And what I'll be able to do is I'll be able to move this 3 to the denominator, because when I multiply, we will get 3 sine 3x over 3x. So now what I can go ahead and do is separate this into 3 times sine of 3x over 3x, and then go ahead and rewrite the limit as x approaches 0. Now 3 is just a constant, and because it's a constant, it can come outside of the limit, so I can rewrite it as 3 times the limit as x approaches 0 of sine of 3x over 3x. Now because the coefficients are the same, we can go ahead and use the limit formula here, where the limit as x approaches 0 of sine of x over x equals 1. So this limit is equal to 1. So we have 3 times 1, which gives us the final answer of 3. And that's how you evaluate the limit using these special trig limits. Now for number 2, we have the limit as x approaches 0 of sine of 7x over 4x. So the very first thing I would do here is we do have a 1/4 as a constant. So I can go ahead and take that outside of the function sine of 7x over x. So we get the limit as x approaches 0 of 1 over 4 times sine of 7x over x. And then 1/4 is a constant, I can go ahead and take that outside the limit. So we have 1 over 4 times the limit as x approaches 0 of sine of 7x over x. Now using our special trig limit, remember that we do have to have the same coefficient there on both the numerator and denominator in order to use the limit. So I notice we do need a 7 on the denominator. So what I'm going to go ahead and do is multiply by a clever form of 1, similar to the last problem. This time we need a 7 on the denominator, so I'll multiply by 7 over 7. Now what we'll get here is 1 over 4 times the limit as x approaches 0 of 7 sine of 7x over 7x. Now 7 is just a constant, I can go ahead and take that outside the limit. So then we get 7 times 1 over 4 is 7 over 4 times the limit as x approaches 0 of sine of 7x over 7x. Now we do have the same coefficients, so we can use that special limit. The limit once again is 1. So we have 7 over 4 times 1, which gives us the final answer of 7 over 4. Now for number 3, we have the limit as x approaches 0 of 5 minus 5 cosine 5x over x. So the very first thing I would do here is go ahead and factor out a 5 to the numerator. So we get 5 times 1 minus cosine of 5x over x. And I can go ahead and shift that a little bit to the right, because I'll write the limit as well. So the limit as x approaches 0. Because 5 is a constant, I can go ahead and take that outside the limit. So we have 5 times the limit as x approaches 0 of 1 minus cosine 5x over x. Now recognize the special limit here, where the limit as x approaches 0 of 1 minus cosine x over x is equal to 0. But in this case we have 1 minus cosine of 5x over x. Now similar to the sine trig limit, if we have the same coefficients on the numerator and denominator, we can go ahead and use that limit. So we need a 5, so I'm going to go ahead and multiply by a clever form of 1 and multiply by 5 over 5. So then we get 5 times the limit as x approaches 0 of 5 times 1 minus cosine of 5x over 5x. 5 is a constant, so I can bring that outside and multiply by that other 5. So then we end up getting 25 times the limit as x approaches 0 of 1 minus cosine of 5x over 5x. Now, because we do have the same coefficient, we can use that limit where the limit equals 0. So then we have 25 times 0, which gives us the final answer of 0.